It's a shield. It's something that kind of protects the atmosphere and the surface of the Earth from all the crazy stuff that the sun throws at us.
It's called the magnetic field, and it's getting weaker by the second. But how it impacts your everyday life might surprise you. NASA is tracking an anomaly within the Earth's magnetic field, which has significantly impacted its intensity. To dig into the details, we tapped a pair of geophysicists, Stephen Burns and Dr. William Brown.
So a geophysicist is someone who studies the physics of the Earth, so it's kind of geology by numbers.
NASA's studies focus on the Earth's inner movements, coupled with solar winds, and how it impacts satellites in terms of computer glitches, data loss, and damage to space equipment, as well as how its magnetic forces affect humans.
So in some ways, it's probably very important to the development of Earth as the planet that we live on, in that we have this nice, stable, very habitable world. It's one of the things that helps to make it that way by protecting us from the radiation that comes from the sun.
The agency's research aims to develop methods to better protect spacecraft and satellites from a weaker magnetic strength. That includes rerouting missions and disabling sensitive tech when it passes through areas such as the South Atlantic anomaly, a region over South America where magnetic strength is abnormally weak, and there is not a clear answer as to why just yet. The Earth's magnetic field is generated by what is known as a geodynamo. Brown explains it is different from what you might think of as a magnet on your refrigerator that has a more static field.
So a dynamo specifically is something that can generate itself, so it's self-sustaining. The dynamo is generating that magnetic field, so it's actually a kind of a loop, a feedback loop, where the change in the magnetic field generates electrical currents, and the change in the electrical currents generates more magnetic field, and it feeds back and reinforces itself and is stable, but it's being generated by all that movement of fluid going on inside the Earth. It's not like the Earth isn't literally a giant solid magnet. It's a kind of active process, and that's the thing that makes Earth's magnetic field particularly interesting.
Geophysicists believe it's vital to study the Earth's magnetic field to protect sensitive equipment needed for space exploration. Here on Earth, it's not only fundamental to protecting us from the sun's radiation, but getting around as well.
We use the magnetic field to navigate in your smartphone, in the GPS system that you have in your car or any other thing. GPS tells you your position, but the magnetic field tells you which way you're facing, like a compass would. So that orientation information is really important as part of navigation. It's the two bits that you need for navigation, where you are and where you're facing. If you have only one of those, you're only kind of halfway there.
Brown says the Earth's magnetic field is subject to changes every 7,000 years or so.
There's two important things to know about that kind of change in the magnetic field. So you've got things called reversals, which are where Earth's magnetic field, so we think of it having a north pole and a south pole, and when they change location and they stay there, that's a reversal. When they move a long way but they go back, that's an excursion.
In excursions, Brown explains, fields migrate but ultimately make their way back. The last major excursion occurred around 41,000 years ago.
The last excursion happened. Like you say, the field got a lot weaker, went down to about 10% of its strength.
Brown says that's where things get murky. The impacts of Homo sapiens at the time are relatively unknown. Some scientists have speculated it played a factor in the extinction of Neanderthals, but Brown says that's unclear.
There have been hundreds of magnetic field reversals and excursions throughout the last few 100 million years that we have documented in the geological record quite well, and they don't coincide with major extinction events or climate changes or any of those kind of big geological events that you can see record of in the rock.
So should you be concerned about a reversal or excursion?
I sleep well as a geophysicist, it's all right. I would say the thing that would be most concerning probably for humans in the modern day is that we've never had a reversal when we have all the technology that we rely on now. So one of the things that happens when you have major solar storms, for example, so that's when the sun throws a bit of its atmosphere out into space and it hits the Earth's magnetic field. That can have a lot of impact on things like power grids, infrastructure, really large-scale stuff across continents, across countries.
Brown points to 1989's massive blackout in Canada caused by severe solar storms on March 13th. Residents and businesses across the region lost power for 9 hours.
There was a famous blackout in Quebec in the 80s where the hydroelectric power system was knocked out by a magnetic storm, and it took a couple of days to get everything back together. That had a massive impact on the businesses. The cost was astronomical in terms of the economic cost of dealing with that kind of thing. So it's that kind of impact that you would expect to be worse during a reversal. If the field was weaker, then the impacts from, say, magnetic storms will be stronger.
Space weather has been affecting our planet since the beginning of time. We live within, the solar system. The sun is the big energy influence within the solar system, and we're only now coming to a more scientific understanding of how that influences our day-to-day.
The Earth's magnetic field is crucial to protecting the planet from space weather. Stephen Burns describes himself as a space weatherman.
I do reports on what's happening with the Earth energetically. You can follow my work at Stephen Burns on YouTube.
So what is space weather?
The sun emits these high-speed particles out into space. Basically, it's always emitting plasma. This makes up the solar wind. We first discovered the solar wind when we first started sending probes out into space, late 50s, 60s, 70s. And so the field of space weather kind of materialized at that point in time, though of course it's been affecting us for millions and millions of years. We're just aware of it now.
Burns says space weather could impact more than just electronics on Earth.
There seems to be a connection between what's happening with the sun and space weather and terrestrial geophysics. So this, for example, could relate to our weather, and it seems to have a strengthening effect on any severe weather that kind of already has the potential to form. So this could be a stronger cyclone, this could be a stronger severe weather outbreak, for example, like tornadoes or hail or thunderstorms.
Burns says auroras seen on Earth are influenced by the interaction between the sun and our planet's magnetic field. He also says cosmic particles interacting with the magnetic field are being studied as a factor in cloud formation as well. But that requires a lot more research.
There's a lot of evidence that they are connected to cloud formation. There's some new research coming out that suggests that these cosmic particles could actually create that ionized channel that within a thunderstorm allows for that lightning strike to all of a sudden occur.
Brown and Burns say the Earth's protective shield remains fundamentally strong. They also say reversals and excursions can take hundreds, if not thousands of years to happen, so it's not likely to happen in any of our lifetimes. For more unbiased updates, download the Straight Arrow News app or go to san.com.